Formula for arc length on a circle. So take a look at this circle. I've got an angle at the center of the circle. Let's call that theta. Let's call the radius of the circle r. Is there a way that I could figure out how long this arc is? The arc that's cut off by that angle theta. Well, the key to developing a formula is realizing that s and theta are proportional to each other, which is really just a fancy way of saying if you were to double the angle, then of course you would double the arc length, and so on. Triple the angle, triple the arc length. If those two items are proportional, then every time I form the ratio of s to theta, it's got to be the same. Well, let's write down one ratio that we do know, and that would be the ratio for the angle that goes all the way around the circle. We call that, of course, the circumference of the circle, and we know the angle that goes all the way around the circle is 360 degrees. That's great, but watch what happens when we switch to radians. Then I can write s over theta, that ratio that I know is always the same, is equal to, remember the formula for the circumference of a circle? 2 times pi times the radius. And 360 degrees, we know that's the same thing as 2 pi radians. Well, look over here on the right side, the 2's cancel, the pi's cancel. I'm left with s over theta equals r. If I then multiply both sides of this formula by theta, I end up with the key formula we were looking for, s equals r times theta. Here is a formula that we've just developed for figuring out the arc length of an arc on a circle given the radius and the angle. It's a great formula and very easy to use, but remember we had to switch to radians to get it. It only works if the angle is measured in radians. Aren't radians great? Thanks for watching.